Hey guys, alright, just to remind you where we ended on the last video. Last video we only did one problem, which is this problem right here. It was really intensive, so that's why we were only able to complete it. We were only able to complete one example. Okay, so on today I'm gonna flip over to the next page. Okay, and what I would like for you to do right now is to try out these two check for understanding problems. Okay. Yes, you are to do this on your own. Both on your own. So hit pause right now. Give yourself about 10 minutes. Try to complete both problems. Keep in mind that you're stating the transformation and graphing it in stages. And at the very end, okay, that means the very last two curves right here, you are to give me the range and the domain of f of x, or in this case, h of x, okay? All right, hit pause. Just go and do it. Hit pause. It's not going to go anywhere. Okay, once you're done, then just hit play again, and then so we can continue with example number 6. And why do I have example number 6? I thought that was example number 3. Let me double check if my pages are right. Okay, I got page 22, 23, and then 24. Okay, so it's not supposed to be example 6. It's supposed to be example, let's fix that. Example 4. That means this is example 5. That means it's example 6. Okay, there you go. Alright, I'm on the right page. I just want to make sure my numbering system was not really working. Okay. Okay, so now that you have done all the graphing by transformations, we are going to do example number 4. Here we go. Okay. Example 4. If, you know what, let me just zoom in really quickly. Focus. Here you go. If 2.5 is a point on the graph of y equals f of x, that means any function at all. It doesn't have to be a square root. It doesn't have to be x squared. It doesn't have to be x to the third. Any function I want to pick. Okay. Part A. Find the point that must be on the graph of y equals f of negative x. So this entire example is just really teaching you whether, or just trying to find, do you understand the notations, right? So this is the parent function, whatever the parent function is, whatever f of x is. So what is the new point if this is the transformation that we are doing? So look at this transformation. Y equals f of negative x. If I said state the transformation, y equals f of negative x is a reflection about what? I'm gonna see if you remember. So y equals f of negative x is a reflection about the, I hope you said y-axis. Okay, is the reflection about the y-axis. So what am I to do? Well, let's plot the point. Here we go. Let's plot it. 1, 2, 1, 2, 3, 4, 5. Okay. We don't know what this function is. We just know that 2, 5 is on it. Okay. And I want to reflect it over the y-axis. Well, all I have to do now is just really fold it, right? Fold this y line. If I were to fold it, let me just get a different color marker. If I fold it, then my reflection point is simply be over here. See that right there? So, here we go, my answer. This is a reflection about the y-axis. I'm really not asking you to state the transformation. I'm asking find the point. So my point is negative 2, 5. And because it's a point, I need parentheses, and I need to box that up. So the change, okay, of a reflection over the y-axis, the input values will be affected. Okay. All right, let's do the B. Find the point that must be on the graph of y equals 3 times f of x. Okay. So what is the transformation when we have 3 times f of x? Okay. Remember, f of x is the same as y, so this is 3 times y. That means the y value of all the y values are getting 3 times as large. So the transformation y equal 3f of x is a vertical stretch factor of 3. Okay? Not just me stating the transformation for you. So what do I do? I already have my dot in pencil plotted, right? The same point, because we're still under the same example. 2 comma 5. Well, if I am going to take this function, whatever f of x is, I'm going to vertically stretching it. Now my new point, which I'm going to write in red, it's going to be positive 2, because vertically x won't change. And then 3 times 5 is going to be 15. So my new point is now 2 comma 15. Okay? Vertical means the y will change. Stretch means I'm going to multiply by 3. And that's going to happen. Okay. All right. So what I wish for you to do right now is hit pause again and try to do this check for understanding on your own. So right now, this is your second set of check for understanding. Okay? On your own. And if you are truly struggling with the check for understanding problems, you need to come and see me, because that means you need extra help. Okay? And again, please hit pause. I'm going to check your answers when I'm stamping it, so just do it right now before you forget. Okay, so now that you have completed the check for understanding in example 4 or example 5, which was formerly known as example 7, suppose that x-intercepts of the graph y equals f of x are negative 6 and 2. So keep in mind, I don't know what f of x is. It can be any parent function that it wants to be. And all I know right now, they have two x-intercepts, negative 6 and 2. So what am I to do? Let's plot those out, right? Doesn't matter what y is. All I know is x. 1, 2, 3, 4, 5, 6. My first x-intercept. Second intercept is 1, 2. We got 2 of those. Okay, it said so. X-intercepts are negative 6 and 2. I got 2 dots. Part A. What are the x-intercepts of the graph of y equals f, which is my original function, of x plus 3? So what is that transformation? What is that even doing, right? State the transformation. So y equals f of x plus 3. It's what? What is that doing? Is it stretching? Is it compressing? Is it left? Is it right? Is it up and down? I hope you said it is a left by 3 units. Okay. So what I'm going to do is I'm going to take this to x-intercepts. I'm going to move it to the left by 3. So what I do have is pretty much, okay, the y values don't change. So let's look at this really quick. This is a formula. Okay. All you do is you take your x and you subtract 3. The y value will stay as y value. So x used to be at negative 6. Negative 6 minus 3 is now, I'm going to write it in red, negative 9. X used to be at 2. 2 minus 3 is negative 1. Okay. And I meant y was 0. Sorry. The x-intercept y is 0, so that's my first point. Another one is negative 1, comma 0. So these are my two x-intercept locations. Okay. X-intercept meaning y is 0. Or you can even write x equals negative 9 and x equals negative 1, and I will be just as happy. Okay, similarly, we are going to do this. What are the x-intercepts now if we are doing this transformation? So y equals f of x minus 2. Okay, so go ahead and state the transformation. Y equals f of x minus 2 is what? Go ahead and state it out for me. I'll give you guys 30 seconds. Okay, hopefully you wrote is moving to the right by 2 units. Okay. And I'm really not, that's not my final answer. That is just me trying to help you out by writing or spelling that out for us, okay? So if I'm moving to the right, let's figure out a formula. If I'm taking this and I'm moving to the right, what's going to change, the x or the y? The x, right? So I'm going to take all my x's and I'm going to add 2. And again, the y value doesn't move. It just stay the same. So I'm going to take this, -6, add 2. That's going to be -4. So my new x-intercepts are -4. Okay. The second x-intercept is 2. 2 plus 2 is 4. So these are my two x-intercepts. Or you can write -4, 0 and 4, 0 because y for x-intercepts will always be 0. Okay. So you pick one, however, whatever method you want to write your answer. Okay, moving on to example C. And again, if I'm going too fast, you would definitely need to hit pause, okay? And so you can finish writing. What are the x-intercept now if I am doing y equals 3 times x? Okay. Remember, we've seen this before. Y equals 3 times f of x, I meant, is this transformation. Okay. Let's spell it out anyway, so it stays in your head. Y equals 3 times f of x is a vertical stretch factor of 3. Okay. Formula, if it's a vertical stretch, x is not going to change. Okay, all I'm doing is I'm taking y and multiplying it 3 times. Well, at x-intercept locations, y is 0. Okay, so 3 times 0, it's really itself. So am I going to change anything with my x-intercepts? No, because the x is not changing. Look at my formula. X is still x. So my two x-intercepts are still at -6 and +2. Okay. So that didn't change. The vertical stretch, okay, did not change my x-intercept. Last piece. What are the x-intercepts now if we have a y equals f of a -2x? Okay. There are two transformations here. The first one, y equals f of a -x. Okay, we saw this earlier, and let's move it really quickly. This is a reflection about the y-axis. So, reflection about y-axis. Okay. Then we have a 2. So, y equals f of 2x. Okay, and then we're going to put them together. 2 inside is a horizontal compression factor of 1/2. Okay. So if I were to write a formula, okay, a formula says a reflection about the y-axis, meaning that I'm going to, according to this piece, right? Remember, reflection about the y-axis, meaning the x is going to change. So I'm going to take my x and multiply by negative. Okay? And then I have a horizontal compression factor of 1/2. So I'm going to multiply the x by negative, and I'm also going to multiply the 1/2 to the x as well. So my formula, when I put the two pieces together, I'm really going to take all my x values and multiply by -1/2. Because these are both horizontal, this is not going to change. Okay, so let's write my answer. X-intercept used to be at -6. -6 times a -1/2, I'm going to have a positive x-intercept at 3 for the first one. So the -6 is now a +3. Then I'm going to take a 2 and multiply by -1. Well, 2 multiplied by -1 is now going to give me a -1. So I have two new x-intercept locations, okay, after these two transformations are done. So keep in mind that when you have the horizontal change, you need to think about its opposite. You need to take its reciprocal, then that will become the factor. Let me move again, because my lights are off in my room because I'm just really sitting here and talking to myself. Woo-hoo-hoo. Come on, lights. Sorry, it's still not coming. I'm going to jump up and down real quick. Woo! Oh my gosh, my lights are really not coming on. Hold on. All right, my lights are not coming on. That's okay. It looks good still on the screen, so I think it's going to be just fine. All right, so those are my answers to example 5, formerly known as example 7. So go ahead and correct that for me. And keep in mind, I will be checking for your 2 check for understanding, so make sure you go and complete them. Okay, let's move on to our last example of 2.5. 2.5, last one. Example 6, formerly known as example 8. Suppose f the function y equals f of x, remember anything I want to be, is decreasing right now on the interval, okay, -1 to 8. So let's sketch that out. All right, it doesn't really hurt. So let's sketch that out. -1, 1, 2, 3, 4, 5, 6, 7, 8. This is just a sketch. I do not know what the function is, but I know that decreasing function, by the way, it does not include the endpoint, so open. And decreasing function just meaning that as I'm going to the right, my y value is going down, okay? So look at this. This is a decreasing function, okay? So decreasing function meaning as I'm going to the right, y gets smaller and smaller and smaller. In this case, it is. Okay, it starts, y starts at 0, and then I'm going on the negative side. And you can put this anywhere. Okay, it doesn't have to be from here to here. An example is I can go from here, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I can start here and go to here. So as long as you have a sketch of a decreasing function, it doesn't really matter where it is. All right. All right, I'm going to erase this because I'm going to need the space to do example B. All right. Over what interval? Okay, so now we have to write it as an interval notation. Is the graph of y equals f of x plus 1 decreasing? Okay, so I want you to think about this transformation for me. Y equals f of x plus 1, stated out for me, is what? And state the transformation. Y equals f of x plus 1 is, state the transformation. Hopefully you said is a translation to the left by 1 unit. Okay? That's it. That's the transformation. That's really not what I'm asking. I'm asking over what interval is the graph f of x plus 1, which is this new transformation, still decreasing. So if I pick up this piece that I have and I move to the left by 1, okay, would you agree that this point, it used to be at -1, would be ending up at -2. So I'm going to have from -2 all the way to, if this point used to be at 8 and I'm going to the left by 1 unit, I am now at 7. Okay, so the interval is still from -2 all the way to 7, and it's still decreasing. Okay, so that didn't change. It's just now decreasing over a different interval. Next, over what interval is the graph of f of x minus 4 decreasing? So do me a favor. I'm going to give you 1 minute. Okay, why don't you state, oops, this is a minus. Why don't you state this transformation for me is a, okay, and then state the transformation. And then try to find the interval. And then in a little bit, how about in about 10 seconds? Or actually, no, I'll give you 30 seconds. I'll come back and write the answer to see if your answer matches mine. Well, as you are working on this, I should tell you a joke, right? Because this is the perfect break time. What's an alligator's favorite drink? What's an alligator's favorite drink? An alligator's favorite drink is Gatorade. Haha, get it? Gatorade? Okay. Transformation. Here you go. F of -4 is a translation to what direction? To the right by 4 units. Okay. So let's look at my answer. If I take -1 and I'm going to the right, so let's count. Let's count. 1, 2, 3, 4. So now I'm starting at +3. See that right there? So +3 all the way over. Remember, going to the right means I'm going to add. So I can take 8 plus 4. That's going to be 12. So my answer is still decreasing, just at a different interval from 3 to 12. Okay, so last 2 parts of the day. What can be said about the graph of y equals negative f of x? So y equals negative f of x. Notice how this is asking, the question is different. Over here it says, over what interval is the graph of decreasing? So it's telling you right now it's still decreasing. Okay, so this question is asking you, well, what is it now if I do this transformation? So let's talk about this transformation. Y equals negative f of x is a reflection. Okay, I'm going to wait, and then you can write down reflection over what? Over the x-axis. Okay. So what can be said about my original? It used to be a decreasing, right? That said so. Suppose the function is decreasing from -1 to +8. Well, what if I take it and I flip it over the x-axis? Da-da-da. What's going to happen? Okay. Let's fold this. Okay. This is still here. Over here, if I fold it, it's over here. So look at that. What can be said? So our answer is that we are going to say it increases, or it is, how about that? It is increasing from, is it changing in terms of the interval? Is it still from -1 to +8? Or did that interval move? The interval stays the same. So from -1 to 8, okay? The only difference is instead of decreasing, it is now an increasing function. And we have to spell that out, increasing from -1 to 8. All right. Last piece of 2.5 notes. What can be said about the graph of y equals f of a negative x? So let's, y equals f of a negative x. It's a reflection about what? The y-axis, right? Because if the x-axis, the negative's in the front, the y-axis, the negative's inside. Okay. Well, this is kind of tricky. Okay. So look at this. If I were to fold it on, let me just sketch another one out here. Okay, this is what we had before. -1, 1, 2, 3, 4, 5, 6, 7, 8. Someone down here, that's that. Okay. If I were to fold it on this line, okay, remember the y-axis. I'm reflecting on the y-axis, which is this piece. This over here is now here. See that? This over here is now over here. So let's count 1, 2, 3, 4, 5, 6, 7, 8. Let's extend this a little bit. So this piece has got to be somewhere over here for it to be symmetrical over the y-axis. So what can be said? What should we write as an answer? Is this piece decreasing or increasing? It's an increasing. Okay, it's increasing from, is it still the same interval? No. Okay, it's not a same interval anymore. It's from -8 now to +1. So -8 to +1. See how reflection over the y-axis? You need to switch these values. Look at that. Crazy, right? All right. That is actually the end of our 2.5 notes. Okay. We are going to start with 2.6. So make sure you guys are ready for your unit test, because right after 2.6 is your chapter 2 test. Have a wonderful day, and don't forget to do the 2 check for understanding problems in your notes. Bye bye.